Okay, let's begin with the first live stream. Today I am solving October-November 24. The variant is 3-1. This might slightly be a difficult exam. Let's start solving and we'll see along the way what problems we have. Okay, this is the first question. This is on polynomials. It says the polynomial. Just open up the marking scheme alongside so I can keep checking my answers as well. Okay. I have the answers right now in front of me, and I have everything else as well. Yeah. Okay. So the polynomial 4x cubed plus ax squared plus 5x plus b, where a and b are constants, is denoted by p of x. It is given that 2x plus 1 is a factor of p of x. So when x equals to minus half, x equals to minus half, y is 0. And p of x is divided by x minus 4. So when x equals to 4, the remainder is equals to 3 times the remainder when x is divided by x minus 2. So there are two situations. The remainder is 3 times. Let's call the remainder r, and this has to be 3r then. Okay. Find the values of a and b. So this is a remainder factor theorem question. So I'm going to first plug in minus half cubed, half squared plus 5 minus half plus b. And I get this comes out as minus 4 over 8 plus a over 4 minus 5 over 2 plus b equals to 0. Okay, because this is a factor, so the remainder is 0. So that's minus half minus 5 over 2 is going to give me minus 6 over 2, which is minus 3. So a over 4 plus b equals to 3. A plus 4b equals to 12. Okay, in the other case, the remainder is 3 times, the remainder is equals to 3 times the remainder. So when I plug in 4, the remainder is 3 times the remainder when I plug in 2. I am a little out of space here. Let's move that here. Okay, so 4 power 4 gives me 256 plus 16a square plus 20 plus b equals to 3 times 4, 8, 32 plus 4a plus 10 plus b. Okay, so we have a lot of the 16a plus 20 plus b equals to 3 times this. So I start solving. Okay, 4a minus 2b, 96 plus 30 minus 256 minus 20 gives you minus 150. I hope that's the correct equation that I'm looking at. Minus 2 minus. Yeah, that is also fine. Then I solve simultaneously. I will do that on a calculator right now to save time, but you should show me a method on the exam. 1, 4, 12, 4 minus 2 minus 1. So A is minus 32 and B is 11. Okay, that's the first question, 5 marks. Relatively long question. The second question says find the exact value of this integral, giving your answer in the form a ln b plus c, where a, b, and c are rational. Okay, that was the previous question. I think I was slightly paused. Okay, then we have the next question that says find the exact value of this. This is integration by parts. So u equals to x squared. Let's first write I late. I think I'm messing that up. So I have ln a. So u is ln 3x and v dash is x squared. So u dash becomes 1 over 3x into 3 and v becomes x cubed over 3. Formula for integration by parts is vu minus vu dash. So I get v, u, v, and u dash. This further gives me x squared over 3. If I integrate that again, that becomes x cubed over 3 into 3. And I have x cubed ln 3x over 3. And I have the limits 1 to 3. So first plugging in 3, so that gives me 3 cubed ln 9 over 3 minus 3 cubed over 9 upper limit minus lower limit. Okay, so 9 ln 9 minus 3 minus ln 3 over 3 plus 1 over 9. I hope I'm doing that correctly. I will just go back and check. Yep, the integration is correct. The limits hopefully will also be correct. In order to do this further, I am going to do this. Minus 3 plus 1 over 9 will give me minus 26 over 9, I think. It's 26 over 9. Yes, that's correct. And there's a minus ln 3 over 3. So that becomes 18 ln 3 minus 29 over 9 minus ln 3 over 3. So 18 minus 1/3 gives me 53 over 3 ln 3 minus 29 over 3. Okay, that is question number 2. Yes, Ali, you have to make sure that you are in the right form. Okay, the third question looks like implicit differentiation. This says the equation of a curve is ln x plus y equals to 3x square y. Find the gradient of the curve at the point 1 comma 0. So I am going to do implicit differentiation. The first thing that I have to differentiate is the left-hand side. The left-hand side has both x and y, so I'm going to say this becomes 1 over x plus y into, now when I differentiate x, it becomes 1. So I write dx by dx with it, and when I differentiate y, it becomes 1 again. This time it becomes dy by dx. Here I have to use the product rule. I think I'm slowing down a little. Okay, so this is u equals to 3x squared, u dash equals to 6x, v equals to y, v dash equals to 1, dy by dx, so u dash v plus v dash u, this is the product rule, 1 plus 1 dy by dx. Okay, find the gradient of the curve at the point 1 comma 0. So I am asking you to find the value of dy by dx when x equals to 1 and y equals to 0. Okay, so that gives me 1. So 1 plus dy by dx equals to 0 plus 3 dy by dx. So 3 dy by dx minus dy by dx gives me 2 dy by dx. And dy by dx is therefore off. Okay. And let's check if that is the correct answer. Yes, that is correct. Okay, question number 3 says show that sec power 4 theta minus tan power 4 theta equals to 1 plus 2 tan square theta. So this can be factorized with the algebraic identity, and you can get sec square theta minus tan square theta is sec square theta plus tan square theta. Okay, so there is an identity that says 1 plus tan square theta equals to sec square theta. That means that this should equal 1, and I have sec square theta plus tan square theta here. So this then becomes I need to change this to tan. So 1 plus tan square theta plus tan square theta. That gives me 1 plus 2 tan square theta. Well, you know, it's not necessary to make dy by dx the subject. हमें objective जो है वो gradient निकालना है ना, तो हम end में भी जो है वो gradient के लिए subject बना के solve कर सकते हैं. So yes, it's not necessary to do that. Okay, the stream is all over the place right now because internet issues. But let's try solving this further. Uh, okay, I am just trying to organize things, a minute, and then I'll continue. Okay. We are on 4b, and it says hence or otherwise solve the equation this equals to this for alpha is between 0 and 180. So this basically boiled down to 1 plus 2 tan square theta. So मैं कह सकता हूँ कि 1 plus 2 tan square 2 alpha is equals to 2 tan square. I have to convert it into one variable. So, okay. Now repeatedly writing 2 alpha is going to bother me. So I'm going to just write x in front of it, and I'll replace it with 2 alpha later on. I can convert this entire thing to tan. Okay, this will cancel out. I have half tan power 4x. I take a root. So tan power 4 fourth root. The fourth root of half will give me tan x equals to, it's going to give me two possibilities. Point 0.841. So 0.841 here and 0.841 minus 0.841 here. Now I know that this wasn't x, this was basically 2 alpha. So 0.841. I mark my quadrants. In this case, I am going to have A and T, and in this case, I am going to have S and C. Let's calculate our basic angle, which is tan inverse of 0.841, 40.1. So tan for quadrant 1, I have 2 alpha equals to 40.1, and I think I may have made a mistake or somewhere. No. Then quadrant 3 is 8.4. Quadrant 2 alpha equals to 180 minus 40.1, and quadrant 4 to alpha equals to 360 minus 40.1. So I have four values for alpha. The first one is 40.1 divided by 2. That gives me 20.05, 20.1. Okay. Quadrant 3 gives me 180 plus 40.1 divided by 2. Okay, 100.1. Now, since the marking scheme says exact values, I have a decimal difference. What the examiner has done is the alpha is more accurate. Okay. The basic angle is more accurate, basically, which is why I have a small difference from the marking scheme. It's this 70. Okay, that's question number 4. Question number 5 says, by sketching a pair of suitable graphs, show that the equation this has only one root. Okay, so I start drawing a pair of suitable graphs. Okay, the graph of ln 1 plus x will be ln x looks something like this. That's ln x. If I have 1 plus x, that means I have to move 1 unit backwards. So the graph of ln 1 plus x will look something like this. Okay. The graph of 2 plus e power minus 0.2x. Okay. Alternate solution. Alternate solution क्या मतलब है? You could convert that into sine and cos and then solve it. That's the other way of solving it if you want. Okay, for 2 plus e power minus 0.2x, you should know that e power minus x looks something like this. Okay, it's going to be, it's e power minus x, going to be downward sloping like that. प्रूफ वाला तो बहुत लंबा हो जाएगा सवाल. It can't give a different, yes, it's going to give a different equation and it's going to be very complicated. क्योंकि उसमें जो है वो फिर साइन पावर 4 आ रहा होगा, फिर जो है वो disguised quadratic बन जाएगी and all of those things, and I think that is more complicated to do for 5 marks. Okay, मैं बाद में करके दिखा दूंगा अभी. Let me just complete the paper and then we'll move on. So 2 plus e power minus 0.2 into 0. That gives me 2 plus e power 0, which is 1. So that's 3. So I'm going to have 3. And then I can also find the value at, let's say, I call it down for 1. So e power is coming out as 2.8, so somewhere there. So this graph looks something like this. Okay, that's 2 plus e power minus 0.2x. Okay, you have to make sure your intersection points are correct. You can't have intersection points that basically x-intercept and y-intercept that need to be correct. Show by calculation that this root lies between 7 and 9. So the first thing that you have to do here is convert everything to a function first and say that 2 plus e power minus x minus 0.2x, basically minus 0.2x. Plus x. You first insert 7. And see what you get there. F of 9. gives me minus 0.137. So change of sign indicates root. Okay. Then I have this question. This says use the iterative formula that converted the previous equation into an iterative formula. To determine the root, correct to 2 decimal places. Give the result of each iteration to 4 decimal places. Okay. So x1 will be the midpoint of this, 8. x2. For x2, I'm going to use my calculator and churn out values as quickly as I can. So I'm going to first type 8 and press equals to, and then write shift e power 2 plus e power minus 0.2 into answer. And then I have a minus 1. So each iteration is to 4 decimal places, 8.04 to 1. That rounds off to 8.04. x3 is 8.0268. That rounds off to 8.03. x4 is 8.0324. 8.03. So 8.03 is the root. I hope that's the correct answer. Let me just check quickly. Yeah, that is the correct answer. Okay, question number 6. The diagram shows a curve this for x's between 0 and pi over 3 over 4 pi and its minimum point m. The shaded region bounded by the curve that lies above the x-axis and the x-axis itself is denoted by r. Given that the x-coordinate of m lies in the interval between pi over 2 and 3 over 4 pi, find the exact coordinates of m. Okay, so a minimum point is basically differentiation. So I am going to differentiate. Sine 2x differentiates to cos 2x into 2. And 1 plus sine 2x also differentiates to cos 2x into 2. So u dash v dash u equals to 0. The next step always is to take a common. That's the easy thing to do. So either this equals to 0 or that equals to 0. So cos 2x equals to 0. Whenever you have 0, you take all 4 quadrants, A, S, T, and C. So alpha equals to cos inverse of 0. Cos inverse of 0 is pi over 2. So quadrant 1, I have 2x equals to pi over 2. So x equals to pi over 4. Quadrant 2 is also pi over 4. So not useful. It's 3 pi over 4. Okay, that's on the edge. That is also a turning point, but that's not the one that I want. Quadrant 4 is obviously irrelevant because it exceeds that bound that I have. Okay, 4 pi over 2, 3 pi over 2, and then 3 pi over 4. That's also 3 pi over 4. Let's try solving this part. So I have T and C. sine inverse of half pi. So I think that should be the correct answer. X should be 7 pi over 12. Let's check from the marking scheme quickly. Yes, 7 pi over 12 is the correct answer. I also need the y coordinate, so I am going to use this 7 pi over 12 in this equation. That gives me minus half 1 plus minus 1 over 4. So x is basically 7 pi over 12 and y is minus 1 over 4. Okay, those are the correct answers. It says find the exact area of the shaded region R. For that, I will first have to find out what the limits are. One of the limits is obviously 0, but I then have to equate this to 0 to find out the other limit. So sine 2x equals to 0, or 2 sine 2x equals to 0, 1 plus 2 sine 2x equals to 0. Okay, I just solved for this, I think. So x came out as 7 pi over 12, but that was this point then. No, that was a different number. I think this is an extra 2 here. Yeah. Okay, that's what's getting messed up. Sine 2x equals to minus 1. B and C. Alpha equals to sine inverse of 1. Is pi over 2. So quadrant 3 is 2x equals to pi plus pi over 2. X is therefore 3 pi over 4. And quadrant 4 is 2x equals to 2 pi minus pi over 2. That's also 3 pi over 4. Now I have to decide, because 3 pi over 4 can't be the right number. I don't have an area up till here. I want to find the earlier coordinate, so I go on and solve this. Sine inverse of 0 is 0. So quadrant 1 gives me 2x equals to 0. Quadrant 2 gives me 2x equals to pi minus 0. So x equals to pi over 2. So this has to be pi over 2. Okay. Then for integration, let's see what sort of integration we have here. 1 plus sine 2x. Let me just check if the limits that I'm thinking about are correct. 0.5 pi, yeah. Okay, for integration, I'm going to do a simple integration of sine into cos 2x minus cos 2x divided by 2 for the first one. Then this is the double angle formula that we've talked about in the past, that cos 4x is basically 1 minus 2 sine squared 2x. So 2 sine squared 2x basically boils down to 1 minus cos 4x, and sine squared 2x boils down to 1 minus cos 4x over 2. So 1 minus cos 4x over 2. I can pull the half common and then integrate 1, which becomes x. and integrating cos 4x becomes sine 4x over 4. I then have to apply the limits throughout. The limits are 0 to half pi. So minus cos 2 pi over 2 plus half into pi over 2, half x, and then sine 4 pi over 2 divided by 8, and then minus cos of 0 over 2 plus half of 0 minus sine 0 over 8. Okay, what's minus cos of pi? I don't want to take any risks, so I'm doing this on a calculator. Minus 1 over 2 plus pi over 4, and 2 pi is should be 0, I think. That's 0. And then minus cos of 0 is minus half, so that gives me plus half, plus 0, plus 0. So unless I've made a calculation mistake, the answer should be pi over 4. Let's check. Pi over 4 plus 1, which means that I've made a mistake somewhere. Okay, so my mistake is probably just calculating one of the numbers. Yeah. So that should be plus 1. So plus 1. Okay, tough question in terms of calculations. Let's look at the next one. It says let f of x be this, express f of x in partial fractions. Okay, so I have 5x squared plus 8x plus 5 over 1 plus 2x. This is a proper fraction, so I don't need to worry about that. It's going to be a over 1 plus 2x plus bx plus c over 2 plus x squared. Okay, you need to get the form of the partial fraction correct. Then you equate the brackets to 0, so x is minus half first. Zero. Two plus 1 over 4 gives me 9 over 4 plus 0. So 9 over 4 and 9 over 4 is equals to 1. Then I go to the other one and I say that now I can take on any values of x because there are no other brackets that are available. So 5 times 0 square plus 8 times 0 plus 5, 2 plus 0 square plus b 0 plus c, and 1 plus 2 times 0. 5, 2a, and c is 1. So C is 3. And then I can take on x equals to 1, I think, because I have all the other values. So I have 18, 3a, 3b, and 3c. A plus b plus c should therefore equal 6. A is 1, b is not known, and c is 3, so b is 2. The partial fractions are then 1 over 1 plus 2x plus 2x plus 3 over okay. Those are the partial fractions. Let's check if they are correct. 1, 2, and 3. Yeah. Okay, hence find the coefficient of x cube in the expansion. So what I am going to do is I'm going to take my expansion, bring it to the numerator, and then try to do an expansion. Okay, for the first bracket, I have 1 plus 2x power minus 1. My a is 1, my b is 2x, and my n is minus 1. So term number 1 is a power n. Term number 2 is n a n minus 1, b power 1, n n minus 1 over 2 factorial. That's term number 3. And term number 4 is n minus 1, n minus 2. 1 minus 2x. And then gives me 4x squared. Then minus 1 into minus 2 into minus 3 divided by 6. Presume minus 8x cubed. Okay, that's one expansion, 1 minus 2x plus 4x squared minus 8x cubed. Let's do the other expansion. The other expansion is 2 plus x squared power minus 1. So a is 2, b is x squared, and n is minus 1. The term number 1 is a power n, it's half. Term number 2 is n, a n minus 1, b power 1. So minus 1 over 4x squared. Term number 3 should be irrelevant, I think, because it's going to give me x squared, and that gives me a power 4, which I don't need. So it's just going to be half minus 1 over 4x squared. Okay. So then I go back and fit in the terms 1 minus 2x plus 4x squared minus 8x cubed plus 2x plus 3 to half okay. So 1 minus 2x plus 4x squared minus 8x cubed. Let's multiply these together. 2x over 2 is this. 2x cubed over 4 plus 3 over 2 minus 3 over 4x squared. Adding the numbers together, 1 plus 3 over 2 gives me 5 over 2 minus 2x plus x gives me minus x. 4x squared minus 3 over 4x squared, 16 minus 3 is 13. And minus 8 minus half should give me minus 17 over 2x cubed. I hope those numbers are correct. I will have to check. No, those numbers are not correct. Okay, let me check where my mistake is. Okay, this just says, I think, find the coefficient of x cube. Okay, my bad. So my x cube is coming out as minus 17 over 2. Yeah, that is the correct answer. So x cube is minus 17 over 2. I didn't notice the question. It said only x cube, but I would have had to do all of these things in order to reach that answer. There was no other shortcut to getting to that answer. Okay, question number 8 is where it gets a little tough. It says given that z equals to 1 plus I and y is a real number, express 1 over z in the form a plus bi, where a and b are functions of y. Okay, so the first thing that I want to do about this is that y is a real number. Okay, so I multiplied with 1 minus y I or 1 minus yi. That gives me 1 squared minus yi squared, 1 minus yi and the okay, so 1 minus yi becomes 1 plus y squared in the denominator. So a is basically 1 plus y squared and b is basically this. Okay, so a is 1 over 1 plus y squared and b is minus y over 1 plus y squared. Okay, that was an easy 2 marks for this. It gets tougher as we go on. It says show that a minus half plus b squared equals to 1 over 4, where a and b are functions of y found in part A. Okay. Squared squared. Okay, without taking common denominator, if I do this, this becomes 1 over 1 plus y squared squared a squared 2ab minus 2ab plus b squared. Then this becomes numerator y squared and then 1 plus y squared squared in the denominator. Okay. Okay, let me just go back and check if I've done this correctly. Yeah, I seem to have done that correctly. Okay. I take a common denominator and there's a 1 over 4. And there's a 1 over 4. The common denominator is going to be 1 plus y squared squared. So this stays as 1. This gets multiplied with 1 plus y squared and this stays as y squared plus 1 over 4. So 1 minus y squared plus y squared over 1 plus y squared gives you 0 plus 1 over 4. Hence proved. Okay. Then sketch on a syndrome diagram, sketch the loci by the given equation z r equals to z, real value z equals to 1 and z minus half equals to half, where z is a complex number. So what I'm going to do is, because I don't have a ruler and a compass on this, I am going to use a grid space. You can't use that on the exam, but just to show you what the exact solutions are, I need to do this. I want to draw the real value of z equals to 1. So I am going to in fact, why don't I just do this? I can use a ruler on my screens. Just use the ruler. 0, 1. So that's 1 on all sides, 1 minus 1 minus 1 and 1. Okay. And real value z equals to 1. So real value z, this is the real axis, this is the imaginary axis. So real value z equals to 1 is basically a straight line at 1. Okay, and then z minus half equals to half as a circle with center half on the real axis. So that's half on the real axis, let's say. And I want to draw a circle that goes up to half. Maybe that's what the circle looks like. Sorry, my bad. So, okay, that's what the circle might look like without the shading. Let me just verify. Yeah, that is the correct loci. There's a complex number z is such that real value z equals to 1. Use your answer to part B to give a geometrical description of the locus of 1 over z. This is the tricky part where I ask you to connect the two parts. So what I am going to do is bring in this. Let's copy this. It's 1, which means that this part is 1. No, sorry. The real value z is 1. Use your answer to part B to give a geometrical description of the locus of 1 over z. So what you've proved here is the equation of a circle, if you notice this. This is the circle with center half comma 0 and radius 1 over 2. Okay. What was A? A was the real part of this. So the locus of z has a real part this and an imaginary part this, which fits into this equation, which means that the locus of 1 over z is going to be a circle with center half comma 0 and radius 1 over 2. Okay, that is how the two things connect, because all of these, when I fit the real part and the imaginary part, if you notice this is basically a distance equation. The distance is always 1 over 4 regardless of the value of y, which means that the locus of 1 over z is always going to be a circle. Okay, z is always going to go around in a circle. Question number 9, the position vector point A relative to the origin. How many questions are there on this paper? 10. There are 2 more questions to go. We are running out of time. The position vector of point A relative to the origin O is this. The line L passes through A and is parallel to 2i plus j plus 4k. State a vector equation for L. Okay, parallel to this, so I'm just going to use A as my A plus lambda, and B, the directional vector is going to be at 2, 1, and 4. Okay. The position vector of point B relative to the origin is this, where T is a constant. The line L also passes through B. Find the value of T. So if the line L also passes through this, then minus T, 4T, and 3T should equal 8 minus 5, 6 plus lambda times 2, 1, 4. So minus T is basically 8 plus 2 lambda. 4T is basically minus 5 plus lambda. And 3T is basically 6 plus 4 lambda. Okay, I can solve any two of these together and then show you that they balance the third. So 4T is going to be minus 8 minus 2 lambda minus 8 minus 2 lambda minus 32 plus 8 lambda minus 8 lambda 27 and 9 lambda equals to minus 3. T equals to minus 2. Is that the correct answer? Yeah, that is the correct answer. The line M has vector equation this. The acute angle between the line L and M is theta, where cos theta equals to 1 over root 6. Find the possible values of A. So the angle between two lines is given by the formula cos theta equals to B1 dot B2 over magnitude of B1 and magnitude of B2. So B1 from the previous question is 214. Okay, and here it's A minus 1 and 3. So that gives me 2 square plus 1 square plus 4 square. A square plus minus 1 square plus 9. And cos theta is basically 1 over root 6. So 1 over root 6, 2A minus 1 plus 12. So 21 A square plus 210 equals to 6 times 4A squared plus 2244A plus 121. 24A squared 6 into 44 is 256, and that's 3A squared 256A and 726 minus 210 by 16. Let me check if that is the correct equation. I have a feeling I may have made an error. 88 and 172. No, I think I made an error somewhere. This is wrong. It's 264. So A is -2 or A is -86. Does the question say find the possible values of A? So both of those are correct. Okay. Yeah. Last question, differential equations. Question number 10. It says a large cylindrical tank is used to store water. The base of the tank is a circle of radius 4 meters. At time t minutes, the depth of the water in the tank is h meters. There's a tap at the bottom of the tank. When the tap is open, water flows out of the tank at a rate proportional to the square root of the volume of water in the tank. Okay. So dv over dt is proportional to the square root of the volume of the tank. Okay, so what is the volume? Volume is pi r square h. So pi 4 square, so 16 pi h. I will need dv over dh as well, so that's 16 pi. I will need the chain rule now. So dv over dh equals to dv over dt divided by dh over dt. So that's 16 pi. I need dh over dt, that's what I want to prove to you. And dv over dt is minus k times root of v. 16 pi minus k, that's 16 pi h. dh over dt equals to minus k, going to be 4 root pi h and 16 pi. So 4 and 4. If I can cancel out this and say that this is root pi in the denominator, so I'm going to get minus k over 4 root pi and root h from here. I don't know if that's correct. Yep, that is correct. Okay. That says at time t0, the tap is open. It is given that h equals to 4 when t equals to 0 and h equals to this when t equals to that. Solve the differential equation to obtain an expression for t in terms of h and hence find the time taken to empty the tank. Okay, so dh over dt is minus k minus lambda root h. So even if you were unable to prove the previous part, you can still do the next part and say that root h comes here. So I have 1 over root h dh minus pi dt. So this becomes minus lambda t plus c and h power minus half plus 1 over half. So that gives me 2 root h. So I have the numbers now. H is 4 when t is 0. So c is 4. And Ali, you have to make some choices in terms of which questions you want to do and which questions you don't want to do. ये 1 mark वाले at times bother करेंगे, even in 2 marks, 3 marks bother you, even 4 marks वाला भी अगर bother कर रहे हैं, do as much as you can. Showing the chain rule and getting everything should also give you some marks, so that's doable. Okay, 75 पे नहीं आता. It comes at a very low mark these days. Last time it was 50. So that means you have a margin of leaving out a few marks and getting a few marks wrong as well. I just need to check if my lambda is correct. Yes, my lambda is correct. So my equation becomes 2 root h 1 over 20 minus t plus 4. Hence find the time taken to empty the tank. So the height is 0. So t comes out as 80. 80, not 80 seconds. Minutes, 80 minutes. Okay, that is the end of this exam. I hope this was productive. I will see you in the next class with a different paper.